Let's do a few more examples. Example 1. Find y prime for the curve x cubed plus y cubed equals 2 times x times y. Remember that y prime means the same thing as dy dx. So again, we apply d dx to both sides. Notice on the left side, we get 3x squared plus 3y squared times y prime. For these problems, when you take the derivative of y, remember to always multiply by y prime or dy dx. On the right-hand side, we have a product of things. Viewing 2x as our first function and y as the second function, we can apply the product rule. The derivative of 2x is 2, multiplied by y, and then we add on 2x times the derivative of y, which is y prime. To solve for y prime, we first get the parts with y prime on one side and everything else on the other side, so we get 3y squared times y prime minus 2x times y prime equals 2y minus 3x squared. We then factor out y prime and divide both sides by 3y squared minus 2x to get y prime by itself. Example 2. Find y double prime of x cubed plus y cubed equals 3x. To find the second derivative of y, we have to find the first derivative first. So we do the implicit differentiation method, getting 3x squared plus 3y squared times y prime equals 3. Solving for y prime, we get that y prime is equal to 1 minus x squared divided by y squared, or 1 minus x squared times y to the minus 2. Now to get the second derivative, we do implicit differentiation again. On the left side, we take the derivative of y prime, getting y double prime. On the right side, we do the product rule. We get minus 2x times y to the minus 2 plus 1 minus x squared times minus 2 times y to the minus 3 times y prime. Notice that we know what y prime is, so we can substitute that into the equation. Our final solution for y double prime is in terms of x and y only. Example 3. Suppose we want to find the value of y double prime of the curve with equation y cubed plus e to the x equals x squared plus 9 when x equals 0. Notice that our final answer will be a number. Since we're going to be working with numbers, we should find out what y will be when x equals 0. If we plug in x equals 0, we get that y cubed plus e to the 0 equals 0 squared plus 9, so y cubed equals 8, meaning y must equal 2. Now we use the equation to find y prime by implicit differentiation. We get that 3y squared times y prime plus e to the x equals 2x. Again, we will need the value of y prime at x equals 0, y equals 2, so we will plug them in to find y prime. We get that 3 times 2 squared times y prime plus e to the 0 will equal 0, so solving for y prime, we get that y prime will equal minus 1 over 12. Notice that I could have solved for y prime first, but it's not necessary here. Now we find y double prime by doing implicit differentiation again. Treating 3y squared as the first function and y prime as the second, we get 6y times y prime plus 3y squared times y double prime for the first part. Then we take the derivative of e to the x to get e to the x. On the right side, we just take the derivative of 2x to get 2. Now to find y double prime, we plug in x equals 0, y equals 2, and y prime equals minus 1 over 12, and then we solve for y double prime. Doing a little algebra, we get that y double prime will equal 11 over 12 divided by 12, or 11 over 144. Again, we could have solved for y double prime first before plugging in the values, but it's not necessary, and sometimes it's easier to work with numbers instead of variables.